Hello, and welcome back to Lemon Lattice. Today we're going to be working on locking sockets. This is part 2 of designing and 3D printing a transtibial below knee locking socket. You can see we have a dummy here of a Bulldog 3 Gen A lock. It's got a 4-hole pattern on the bottom. It's got a tapered top to match with the umbrella of liners. It uses pin locking suspension. And we're going to create the housing for that with all the holes and everything cut into it. There it is. So, let's see when that goes in. We've got it all built in. So I don't like to have to drill and cut and do all those things at the end after I print. There's just no need for it when we can design it in. And then you're not running the risk of potentially breaking your print by doing extra work to it. So let's get started here. I believe Bulldog may also offer CAD models of some of their parts. So reach out to them. I think I heard that. But this is one quick way to model something like this. So let's start fresh and I'll show you how this works. We're going to go create sketch and click here. I want to work from the top down. And then we're just going to do a center circle. And these locks are 65 millimeters in diameter. And we'll go finish sketch. And then they are 25 millimeters tall. So just that easy. We have a very basic dummy of it, but let's also get that taper built in. So if we look here, I'd measured these previously. This sketch, we've got 7 millimeters as the depth of that taper. So we're going to create another sketch. And by drawing this circle on the center point at the origin, we now can click this plane and know that we are at the center of that. So we're going to add a line. Well, before we do that, let's actually project the lock itself. You can see it added these purple lines, which are derived from that lock geometry. You cannot add that dimension because it's already derived. You can have it there as a reference, but you can't change it. But let's add a line, and by having these here, we can now snap. We can hover and snap to the center. And we can come down 7 millimeters and hit enter. And the hotkey to add a line is just L. So I can click L and connect that and finish off that shape. Now when we turn off that body, you can see we have a selectable shape. So let's finish sketch. And now what we want to do is take that and we want to cut that in a circle. So we turn that body back on with that already selected, because if we don't have that selected, it can be kind of hard to grab that since it's inside of the other body. But the tool we want here is revolve. And you see you can't easily grab that, so turn that off. Just cancel there. So revolve. There, we've got that. Turn that back on because we need to cut from that body. And then we need to pick an axis. So we could pick this center axis here. And that's what we want to do. You could also pick this line. Either way, let's click that line. You can see that's now going to cut that in a 360-degree circle. You could make it less, that is how the revolve tool works. You can cut or build with it. And it's a little hard to see here with the rendering, but that is now tapered. You can see it right there. You can also do a section analysis. So inspect section analysis, click a plane, and then you can see what the cross section of any shape looks like. I use this when I'm actually designing sockets to make sure I have my socket on top of my lock properly for a clean transition from the lock right up into the walls of the socket. I don't want the lock to be higher or lower than that and have pressure points. So I will use this section analysis tool to make sure before I go to printing that everything is clean and correct. But I don't actually want to keep that, so I'll just hit cancel. I just use that as a visual tool. So that's a dummy. What you could do is right click there and do save as mesh, export that, and then bring that into Mesh Mixer, which is what I do. I use this tapered top to actually shape the bottom of my limb in Mesh Mixer to match this perfectly for the best, cleanest socket design and transitions. But let's also now take that next step and design a housing to go around this, because you can also just use that when you're designing your socket. You don't really have to add the lock. You can also just add the housing. So we're going to work off of that same sketch. Let's go back and edit sketch. And a couple ways here to do this. You could add a new circle and come out. And we want this one to be a little bit bigger. This is the housing around the lock. So we want it a little bigger than the lock so that things aren't too tight going in. So that lock is 65 millimeters in diameter. I want to make this housing 66. So I have a 0.5 millimeter on each side of space. That should be more than any potential print error. If you are printing these and find it's too tight, just make this a little bigger. It doesn't really matter as long as you don't get so big that things are sloppy. Let's start at 66. And then what we want is a 4 millimeter wall off of that to actually be the wall of that housing in the 3D printed product. So we can use this offset tool and then click that, and we can come out 4 millimeters. You could also take things in, but what you can't do is offset something that's already an offset. So you have to click an original circle. So let's finish that sketch and then turn it back on right there so that we can see it. What I want to start and do, we know we have that lock going up. I want to grab all 3 of these sections. There are 3 parts here that can be highlighted. So I want to grab all of those and bring those down 5 millimeters as my base plate underneath my lock. And then I want to grab just that 4 millimeter wall and bring that up 25 millimeters to match the height of my lock. So those were new bodies. The first one I did was a new body, and the second extrude was a join because I wanted those to be one piece. So let's come now to the bottom of that lock, click it, and create a sketch. And what we want to draw is that 4-hole pattern. So the patterns that we use in prosthetics are 36 millimeters on center across those holes. And we use 6 millimeter diameter screws typically. So when designing for 3D printing, just know that when you print those holes are probably going to come out smaller. So we're going to oversize them a bit. I'm going to make them 7.5 millimeters. And if they're going to be 36 millimeters across, we need them 18 millimeters from the center. So we can click that. You can see right now it wants to dimension there, but if you drag up or over, you can change which dimension you're getting. Let's do 18 there, and come out and do 18 there. So that's one hole. We could do that for all four, or you can do some different things. Like you can create circular patterns, you can create rectangular patterns. I'm actually going to show you how to mirror. So we're going to select that circle as our object, and then we need a line to mirror over. Now we can't mirror over these dimension lines, but what we can use in this case is the origin has both planes and the axes. So we can select those axes as mirror lines. See, once we click that, it has now created a second circle, and it's put this this geometry in. It's projected this little line here, and you can see these small things are constraints. So that is the mirroring constraint, showing that that is part of that. If you were to delete that line, you lose the constraint, and that can be moved anywhere. Control Z a couple times. Let's get that back. Now I cannot move this because it is constrained to mirror from this, but if I change that one, that changes with it. So one more time here, we're going to mirror again. We're going to do both of these and mirror them over this axis. And now all four of these are connected and derived from this first one. So that's our 4-hole pattern. Let's put a center hole in. Let's just make that 12 millimeters, oversize it relative to the pin a little bit, and finish sketch. And now you can see we've got all of these are selectable. So let's extrude, click them, and you don't have to hold control or anything here when you're within a tool. You can just start left clicking and adding them on sequentially. And we're going to cut, and I'm going to do a through all and give it the direction that you want it to cut. So you can see we could just pull it up there, but now if we go all, it'll cut through that plane and anything else that might be in its way vertically. So that's now coming together. You can see we would have a lock that would fit in that housing. And the last thing that we're going to need is some sort of hole there for the button. So that button is a little over 12.5 millimeters in diameter. And you can see that it basically sits on the bottom. So the bottom of the button matches up with the bottom of the plate. So at a minimum, we would need a 12.5 millimeter diameter hole, but then that would be really hard to get in and out. So we're going to make this opening quite a bit bigger just to make things easier. So to get started, we have to be able to draw the shape we want. We're going to cut a shape through. We have to draw that shape outside and bring it in, or draw it inside and bring it out. So let's do this. Let's put a plane on the outside would be one option. So construct offset plane, click the one you want, and you can create a new plane to work on. And that would put it if you know what side you want it on, or if something's not in line with an existing plane. There's lots of ways to create planes here. In this case, I'm actually going to design it here. Oh, that was, let's back up, Control Z. I think I clicked the wrong one. So I want it on this one. And I'm going to design one shape in the middle that could be cut left or right, depending if it's a left or right limb, if I want that release button medial, if I wanted it lateral. I can choose where to put it. So let's grab that and project that shape to start. The other thing I want to do is project this bottom. I want to know where the top of that plate is. So I'll project that as well. You can see now I have 1, 2, 3 lines of projected geometry, and it's actually showing me where the hole locations are too. So at a minimum, we would need a 12.5 millimeter hole. We're going to go bigger than that. I don't actually like to use circles for things like this, because as that's 3D printing, you're going to get to this top part, and it's going to have to do some sort of bridging here, and that might start to droop filament in. Might not matter, but it could be something you have to come back and clean up later. So that's why I prefer to use things with 45-degree angles, because they print really clean. So let's start here. We're going to start along this base plane, and I'm going to draw a rectangle. And for mine, I have these at 20 millimeters. And then on the constraints, what I want to do is a midpoint. I want that line that I just drew for that rectangle mid-plane with this line, or midpoint with that line, I should say. So now it's centered up. So because that's 20, I can't grab these and move because it's already fully constrained. What I could do is move that up and down, because this has not been dimensioned or constrained yet. Let's make that at, let's go 13. So bare minimum would be something like that. But now I want to add those 45-degree angles for cleaner printing. So I can come out here. Right now it wants to give me the length, but if I hit tab, I can actually add the angle. And then I can grab and drag that to the center. Actually, I'm going to go a little bit past and show you this tool. Hit L for line. Grab and come out. Let's do 135 as the reverse angle. And now you can see we have this shape. They're intersecting and crossing over, so we can trim those extra parts away. We can trim right there. And now we have just the shape that I want. I'll finish sketch. And that is what I will cut. So I can grab that and cut that way. I can cut that way. And now you can actually export this housing, again, to Mesh Mixer. And you could use this top edge to blend Boolean that into a 4 millimeter thick socket in Mesh Mixer. So I'm going to cover a lot of ways to do it. Any of these kind of blending, cutting, joining operations are going to be much better, much cleaner in Fusion 360. So I would recommend learning Fusion 360 for those kind of things. But they can be done in Mesh Mixer. But because you're working with meshes instead of solid dimension bodies, things will blend and get a little bit messy. You might lose some of your dimensions. So just know that there are ways to do it. There's not a best or worst way. It's whatever works for you and your workflow. So we're going to cover a lot of those options. So check back for part 3, which is where we'll take some of these things we've made here in Fusion 360. We'll put them into Mesh Mixer, and I will join everything up and show you several ways to make locking sockets with the Bulldog 3 Gen A lock. So thanks for watching, and we'll see you at the next one.